Part 4. Differential statistics. This is a decision tree which is used by the researcher of the test to determine the correct test for them to use to conduct their research. There are different routes that you can go down, which is shown here, and there are many different reasons into why you would use each different route. The Wilcox match pairs test required ordinal data and to have differences between related rankings. It is a non-parametric statistical hypothesis test used to compare two related samples. Matched samples are repeated measures on a single sample to assess whether their population mean ranks to differ. When using the Mann-Whitney U-test, the data will have to be ordinal and have differences between unrelated rankings of two groups. The Mann-Whitney U-test is used to compare differences between two independent groups when the dependent variable is either ordinal or continuous but not normally distributed. The Mann-Whitney U-test is often considered the non-parametric alternative to the independent t-test, although this is not always the case. Finally, the chi-squared test is needed for you are working with when you are working with nominal data and there are differences among frequency counts in the data. The chi-squared test is used to determine whether there is a significant difference between the expected frequencies and observed frequencies in one or more categories. A chi-squared test can be used to attempt rejection of the null hypothesis that the data is independent. There are then four different equations that you can use. In Spearman's, you have two sets of data. With these sets of data, you need to rank them from lowest to highest and put these in the rank column to the right of them. If some numbers are the same, they are the same rank, but you just put them in order in brackets so they still fulfill how many of them there are. So if three numbers were the same, they would all be ranked 4, for example, but one would be ranked 4 brackets 4, the next being ranked 4 brackets 5, and the last being ranked 4 brackets 6. Then once you have all of these ranks, you find the differences for all the participants' ranks when they had in the first set of data and then they had in the second. And then following this, you square the rank, put this in the final column next to the rank difference column. You also need to find the amount of participants and put this in the row below. Participants and then also square the amount of participants and put this in one row lower again. Finally, you need to find the difference, which will always be 0, and then all the differences squared added together. Once you have done all of this, you have all the numbers needed for the equation and can do the equation. Once this is done, you need to do the critical value table where you need to subtract the number of participants by 2. So for us it was 10 participants, so 10 minus 2. Then with the degree of freedom, the rows and the significance level is 0.05. You need to find where n minus 2 meets with the row 0.05. Where for us this was 0.74, which is the critical value. And if the critical value is bigger than if the calculated value is bigger than the critical value, there is a significant relationship, and if it is smaller, there is not. This was not the case for us as the critical value was bigger, as it was 0.74 and the calculated value is 0.13, so therefore there was no significant relationship for our testing. With the Pearson's test, you start off by having to fill out the table where you need to find the sum of x for the participants. Then once you have found this, square all the sums of x. Once this is done, you are required to find y, and like with x, square all the sums of y and then find xy, which is x times y. Following from this, you then need to add up all the columns apart from the participant one, where you need to find the amount of participant, and with these answers that you have found, put them in the box below the columns. Once this is done, you need to square the answers you got in adding all of the x and y, and then place these in the rows below as well. Once this is done, you have all the numbers needed to do the equation, which is what you will do next. Finally, once you have done the equation, you have to find a critical value from the level of significance, the degree of freedom, and the rows and the rows and the significant level is 0.05, and it's the row and where they meet in the tables is the critical value. Once this is found, you then use the calculated R value, which allows you to see if the testing was significant. This is the case if the R value is below the critical value, it is not a significance difference. However, if it is above, then there is a significance difference. Where the critical value for us was 0.7067, where the R value is above, so for us it has a significant difference. In the independent t-test for the graph, you put two of the same testings but different data. So, for example, you could use two different groups or it's similar testing, and then find the mean and standard deviation for both of these results that are put in, and put these in the rows below the data, and then you have all the data that is needed for the equation, which you will do next. From doing the equation, from this, for the critical value table, you need to add the amount of participants for both testings and take away 2 to your answer, where we got 18 then because the degree of freedom in the rows and the significant level is 0.05, you need to find where your answer is. It was 18 for us, and where this links in the row 0.05, where we had the answer of 2.101. If the calculated value is bigger than the critical value, there is a significant difference, and if smaller, there is not. This was not the case for us, so there was no significant difference in this testing. Finally, the dependent t-test. In this one, you again get two sets of the same testing, but this time the same participants doing it, but with a difference when they do both of the testings, where the researchers will normally be looking to see if there's a change from this difference. You need to find the difference in their scores and square this difference, and then once this is done, you have all the numbers needed to do the equation that you will put in the table. Following on from when you have done the equation, you need to find the critical value, which can be done by getting the number of participants and minusing 1, and because of the degree of freedom, the rows and the significance level is 0.05, you need to look across from n minus 1, this was 5 for us, and in the 0.5 section, what the number is, where for us it was 2.571. If the calculated value is smaller than the critical value and there is no significant difference, but if it is bigger, then it therefore is significant. This was the case for us as the calculated value was bigger, so in our testing it was significant.